Everything begins here. Vast aloe vera fields where the raw plant grows naturally, cultivated at massive scales.
These mature aloe leaves store the clear gel deep inside their structure, formed naturally through slow growth.
At full maturity, these aloe fields represent the large extraction.
Before extraction begins, the aloe plants are left intact at peak maturity, ensuring maximum gel volume across millions of units grown in parallel.
At the base of each plant, gel-rich leaves have fully developed. This is the last natural stage, where
Before any industrial action begins, these fields are mapped and monitored as a single biological resource.
After months of natural growth, the aloe fields reach full readiness. This entire landscape now represents raw material waiting for industrial extraction.
Industrial extraction begins. Massive automated harvesters move through the fields.
Each leaf is separated with precision. Automated cutters and conveyors ensure continuous high.
Once cut, the aloe leaves are immediately lifted and organized by onboard systems.
Extraction is never isolated. Entire fleets operate simultaneously, transforming millions of aloe plants into harvested raw material every hour.
Freshly cut aloe leaves are transferred immediately to large field conveyors, keeping material in constant motion towards centralized industrial handling.
At the collection point, harvested aloe leaves accumulate in bulk. Here, volume is measured in tons. Before transport, the harvested aloe is compacted. Automated systems increase density, allowing it.
Compacted aloe is loaded directly into heavy transport units. Each truck carries tons of raw material, ready to move. Once loaded, the raw aloe begins its journey. Convoys move continuously, transferring biological mass from the fields to industrial processing zones. Bulk transport now takes over. Dedicated industrial routes move enormous quantities of raw aloe efficiently toward large-scale factory processing. Through dedicated logistics corridors, raw aloe travels in constant motion. Every shipment is tracked in real time. Automated logistics systems ensure a constant, measured flow of aloe toward the processing complex.
Where volume increases further, bulk transport shifts to rail. Automated terminals transfer aloe at scale, accelerating delivery to mega processing facilities.
Rail transport takes over for extreme volumes. Entire trainloads of raw aloe move continuously, feeding the demands of large-scale gel production. At this stage, transport itself becomes industrialized. Entire rail systems operate continuously. The raw aloe reaches its destination. This mega processing complex is built to handle.
Unloading begins at full scale. Automated systems empty entire rail cars at once, feeding raw.
Inside the factory, intake lines stabilize the flow.
Automated sorting begins immediately. Industrial gates separate material by size and condition, ensuring.
Once sorted, approved aloe material is consolidated. A single high-capacity line now carries the raw plant mass.
Industrial washing begins. Massive rotating drums remove soil and surface impurities, preparing the aloe for high-volume gel extraction.
After washing, purified aloe moves forward immediately. Water is recovered and reused.
Trimming systems refine the material. Automated cutters remove outer layers at scale, isolating the gel-rich inner aloe for industrial extraction. Filleting begins at full scale. Industrial machines separate the clear aloe gel from the leaf structure, producing pure gel material in continuous flow. Separated gel now becomes the primary product stream. At this point, massive volumes of pure aloe gel move deeper into the factory for refinement.
Gel refinement begins here. Industrial crushers convert solid gel into a uniform pulp.
Once pulped, the aloe gel is transferred under pressure. High-capacity pumping systems move the material continuously through the factory without interruption.
Thermal stabilization begins. The aloe gel is gently heated at industrial scale to neutralize biological. Heat is applied evenly and continuously. Industrial exchangers maintain precise temperatures.
Filtration refines the gel. At this stage, industrial systems remove remaining solids, producing a clean, uniform aloe gel stream. Centrifugal separation adds another layer of purity. High-speed systems remove microscopic residues, leaving a consistent industrial-grade aloe gel. Homogenization refines the gel structure. High-pressure industrial reactors ensure uniform texture and consistency across massive production volumes. Large-scale blending stabilizes the gel. Industrial mixers maintain uniform composition across thousands of liters, moving through the system continuously. Air removal is essential at scale. Vacuum processing eliminates trapped gases, ensuring a dense, stable aloe gel suitable for industrial use. Viscosity is controlled next. Industrial conditioning systems fine-tune gel thickness, keeping texture consistent across massive production volumes. Microfiltration continues the refinement process. Inline industrial filters remove remaining stabilization reactions take place here. Industrial reactors control biochemical activity, ensuring the aloe gel remains stable during large-scale processing.
Controlled maturation follows stabilization. The gel is held in motion under precise conditions, allowing its structure to settle evenly at industrial scale.
Final texture polishing takes place here. Industrial homogenizers eliminate micro-variations, deliver.
Chemical balance is fine-tuned continuously. Industrial control systems adjust pH and stability parameters.
Thermal equalization stabilizes the gel. Industrial cooling systems bring temperature into balance, preparing the product for the final processing stages. High-pressure shear processing completes structural refinement. These systems ensure the aloe gel achieves uniform flow behavior across industrial volumes. Polishing reactors finalize internal consistency. At this stage, the aloe gel moves as a perfectly unified material across continuous industrial flow.
Recirculation balances the gel flow. Industrial loop systems equalize consistency across massive volumes.
Consistency is verified. Industrial monitoring systems confirm the gel.
Flow stabilization is critical at this scale. These channels calm the gel movement, ensuring uniform behavior.
Buffer reactors regulate continuous flow. These industrial holding systems maintain stability and volume balance before the gel proceeds.
Rheology control follows. Industrial systems measure and adjust how the gel flows, ensuring predictable behavior across massive continuous volumes. Texture conditioning completes the core processing phase. These industrial systems ensure the aloe gel maintains uniform structure at full production scale.
Flow calibration aligns the entire system. Industrial manifolds balance pressure and volume,
Keeping the stability is reinforced continuously. Inline industrial chambers lock the gel's internal balance, ensuring consistency as production volumes remain extremely high. Structural integrity is maintained here. Industrial processors ensure the aloe gel remains cohesive and stable while moving at full production scale.
Purity is actively maintained. Inline industrial systems monitor and correct the gel in real time. Flow equalization columns balance movement across the system. At this scale, uniform velocity is
Density calibration ensures uniform mass distribution. Industrial reactors adjust internal balance so splits. Flow harmonization aligns every stream. At industrial scale, these chambers ensure the gel moves as residence time is controlled with precision. Industrial reactors ensure the aloe gel remains in processing for exactly the required duration at full production scale. This marks the final processing corridor. The aloe gel now flows fully stabilized, uniform, and ready to exit the core industrial processing phase.
Core processing is complete. The aloe gel now exits the industrial processing phase, fully stabilized.
Processing has ended. The finished aloe gel is now held in industrial buffer tanks, maintaining stability.
In this stage, the gel is simply maintained. Automated circulation preserves uniformity and readiness. The stabilized gel now transitions forward. These channels do not process, they simply stage the product for industrial finishing operations. All finished gel streams are synchronized here. This step aligns flow and timing, preparing the product for uniform industrial finishing. The aloe gel is now fully prepared. These chambers maintain final readiness, ensuring the product remains unchanged before finishing begins. Before formal testing begins, the gel passes through non-invasive verification. These systems confirm readiness without changing the finished product. All systems are now aligned. The finished aloe gel stands ready, with every industrial parameter locked before quality testing begins. Sampling systems are positioned. The finished aloe gel is prepared for controlled quality checks, with no disturbance to its stabilized state. Final readiness is confirmed. All parameters are verified without contact, ensuring the aloe gel is fully prepared for industrial quality testing.
Quality control begins with automated sampling. Robotic systems extract precise gel samples at scale without disrupting continuous production.
Physical properties are tested next. Automated systems measure viscosity, clarity, and flow behavior, confirming consistency across industrial batches.
Chemical and microbial integrity is verified here. Fully automated analyzers confirm purity and
results are compared against industrial standards. Automated systems validate every parameter, confirming that each batch meets exact specifications.
Quality control is complete. The aloe gel batch is approved, meeting all industrial standards and cleared for large-scale finishing and packaging.
Approved gel now enters the finishing stage. Industrial silos release the product in controlled flow, preparing it for large-scale packaging. Sterile filling begins at full capacity. Automated lines dispense the approved aloe gel into containers with exact precision and zero contamination.
Each container is sealed and verified instantly. Audit systems confirm integrity at scale.
Finished containers are labeled and coded. Industrial traceability systems mark every unit, locking identity, batch history, and destination at full scale. Packaging moves to bulk form. Robotic systems palletize finished containers with precision, preparing large volumes of aloe.
Finished products enter controlled storage. Automated systems manage vast inventories, keeping the aloe gel stable and ready for distribution. Distribution accelerates beyond the factory. Approved aloe gel leaves the facility in bulk, entering global industrial supply networks.
Final logistics verification completes the cycle. Every shipment is cleared, balanced, and documented before leaving the industrial system.
Distribution moves outward. Finished aloe gel travels in bulk, extending the industrial process into national and global supply chains.
From land to sea, the supply chain continues. Industrial-scale shipping carries aloe gel across global markets.
The journey continues across oceans. Massive shipments of aloe gel move as part of a global industrial supply network. Upon arrival, shipments are distributed regionally. Industrial systems route aloe gel to its final markets, completing the supply chain.
From raw plant to global supply, this is industrial aloe vera gel, produced at massive scale.
After the journey ends, the purpose begins. Industrial aloe vera gel becomes care, comfort, and healing.